to a new live, a new Mardini session for this year. First of all, like on other occasions, let me know if you can hear me well and if you can see the video correctly. I also checking, like the other days, checking a few technical stuff with the OBS. I still need to take a look to some settings to improve the streamings. I promise that hopefully on the next live the quality will be slightly better. I still don't know why the streaming is not in 4K and is still at 1080 with 60 FPS, but yeah, maybe tomorrow or next week I can fix that. So welcome. In case that you are new here, this year I am doing my Mardini challenge like previous years, but the new proposal is about to share a little bit of the process with you with this kind of lives. Sometimes I can show you how I start from scratch my Mardini entries. Sometimes I can show you like look development. Yeah, the idea behind this is to make it like a very organic videos with not too much of stress. Yeah, for example, today I actually what I'm going to do today is to finish the entry from yesterday because I didn't make it on time. So I thought that might be a good idea to show you how a few tricks like on how I can do like some final details to finish my yesterday entry, which was environment. The topic was environment. I don't know if the daily winners are already announced, but there are like a lot of pretty good artists participating also on the challenge. Also, I want to invite you to participate this year. You don't need to worry. You don't need to make the entire challenge because it is a lot of work. The special thing that we have for this year is that Side Effects is giving a 2 month license of Houdini Indie for free. So you can use that license to participate on the challenge and make the renders without any kind of resolution limitations or something like that. You can see like the actual information about this on the Side Effects website. So take a look into that. Okay, before jumping in, I want to also check the quality of the interface. Actually, I also forgot to share. Give me 1 minute, please, because I forgot to share the live streaming on my Instagram account. So just in case there is someone there that want to join into the live. So give me 1 second. Actually, just let me know in the chat if you can hear me correctly. The sound is a bit loud. Okay. let's just dive into Houdini. Give me 1 second to reorganize the windows here and find the OBS to change the screen. Okay, so let's dive into this. I also want to see the quality of the Houdini interface. Okay, definitely it's not the best. Because of this, in the meantime, meanwhile I update or change some settings on the OBS, I am uploading a high quality recording right after finish the live. So don't worry if maybe you can see a text or something on the screen. You will be able to check the video with higher quality later. Okay. As I already told you, let me actually enable the render here just to show you what we have. Today's live will be focused on finish this entry. I created like a little environment inspired on the Scavenger's Reign series, which is a pretty nice series, animated series. In case you haven't seen it yet, definitely you should see the series. It is pretty good. So it's like I have this kind of, I don't know, organic rock element, kind of coral but on exterior scene, with some a sort of seaweeds, plants scattered into the space. I like how it is looking right now. The final touch that I want to do is related to the little particles. I have like a little spores coming out from the big element, and yeah, I think that I want to add a few more particles into that. Also add a little randomizations on the size of the particles. Yeah, well, that's the main thing. Based on that, we can change the color. Yeah, maybe we can close the scenes just with that. Also, please don't forget to subscribe to my channel, and I also want to take this opportunity to mention that this is like a toon render that I created using the Toon Studio. Let me show you that here very quickly. This is like a toon materials for Redshift created by the You and Me guys. This is like a 100 library of toon elements. Let me close this one. It is pretty cool. There are a few very interesting materials. I helped them to create the Houdini version, so it is a pretty good one. If you want to experiment with some toon stuff, maybe you can consider to acquire the library. Okay, let's disable the render and let's jump into the scene. Right now, I assembled everything in Solaris. I started with a subcreate, but at this point this should be a subnetwork and not a subcreate because I just ended up by creating everything inside here and then call everything outside in Solaris. So this is the elements that I have. I have like a kind of heel. I have the trunk, we can call it like that, or a coral element, which is this organic piece. And then I have the particles, which are called the spores, and we have the seaweeds here also moving with the wind. The only simulation here is on the particles. The seaweeds are just like a two layer of noise moving those splines. So beside that, well, there is a maybe an interesting work on how I created the coral stuff. Maybe I can show you that later on another day. Just let me know if you are interested to know how I created the main coral body. Okay, here also how I created. Also, let me enable the template on the coral. How I created the particles. I just created a basic smoke simulation using Axiom Solver, which is a GPU solver to create smoke, fire, fog, that kind of fluid simulations. And it is pretty fast. I usually prefer to use this instead of the minimal GPU solver for pyro simulation. I know that there is people that prefer to use the minimal solver, but what can I say? I prefer the Axiom one. Here I added a little bit of retime and I have my particles. So I told you that I want to add a few more particles, and also maybe we can add like a little time shift here. So they can be more evident on the space. Let's also increase, let's disable the outside visualization. Let's increase the amount of particles. Maybe some, I don't know if 5,000 might be too much, but let's see. Yeah, I like this kind of movement. So yeah, I told you this thing actually was basically ready. And they can be just like a little circles. So I don't know, maybe I'm going to reduce the amount just a little bit, maybe the half of them. Yes, I prefer this. Let's make sure that everything is computed correctly by resetting the simulation. And okay. Now, I'm going to do two different things. I'm going to create a p-scale attribute to control the scale of the particles, but also they should be randomized. And I'm going to create a kind of reveal transition for the appearance, because right now they are already created on the space, but maybe we can add like a more interesting layer where they can born by increasing their size, so that will add a more interesting effect. Let's do that by just simply adding attribute randomize node. This should be the t-scale. The important trick here, if we want to add a constant p-scale value to the particles without having flickering, let me actually change the particles visualization to lit spheres. What attributes do I have here? Okay, maybe let's move this one to below. Okay, I have the ID, which is an attribute created by the pop network, the velocity, and the position, of course. So I kinda create the p-scale value. Don't forget to reduce the dimension to 1. So now it is working correctly. So maybe actually I can create a randomization between 0 and 2.5, but also reduce the global scale, just to have a more contrast on their sizes. But here's the thing. If I move the timeline right now, well, actually they are not popping up because the point number is constant, but just to make sure, and for those kind of simulations where you are creating new points on each frame, you should enable the seed attribute. So it's like the seed attribute of the particle, sorry, the attribute randomized will be guided by this seed attribute. So this is a pretty important detail. Maybe increase the size a little bit, something like this. I think that we can try it into that size. Okay, we are almost there. Now I want to add this animation that I told you, where they can kind of sort to get the final size after traveling a little bit. So for that, we will need the age attribute. So let's recover that one from the attribute delete. Here I have now my age attribute, and let's find, maybe disable everything here, all the attributes, just to check the age attribute. I can see that I have an age with a value between 1.6 and 1.7. Let's create an attribute wrangler. I created this setup like a lot of time, but every time I create it on a different way because I always forgot to save it. Here is where I maybe I should consider to save this setup as a recipe or in another way, like a snippet, like this kind of snippet. So we have our P scale. We're going to multiply it with a multiplier beta that I'm going to create. Let's create a float variable, which will be our mult variable, and also we are going to create a fit. The fit expression will be our main guy here. So the base of the fit expression will be the age. The values will be between 1.5, or actually maybe it will be easier if I just create an interface parameter. So let's call this like a mean age, or actually age minimum, and also let's create another parameter which will be called age maximum. Okay, and this should be remapped between 0 and 1. Let's create our values, and actually this and why not, let's create another attribute called debug, just to have an attribute for debugging the data that we are remapping on the multiplier. So this will be equal to the multiplier, and actually let me increase a little bit the size of the Wrangler node. Okay, right now the debugging is 1. That's why we don't see any change here, but we're going to use it. Okay, this should be something like I am telling into this expression. So when at the moment that the age is 1.4, it will be a 0 value. So the size of the PSK will be reduced, and at the moment when the age will be 2, which is what I defined here, the multiplier will be 1, which means that the size of the PSK will be the original one. So if this is true, actually let me update the name of this node, PSK by age. Maybe add a little color into it and just press play. I can see it was very fast, but they increased their size based on the age. So let's start to improve this thing a little bit. Maybe increase the age a little bit more so they can take a little bit more time. And it is looking nice, but to make it look more interesting, like everything, we should add a little bit of randomization. So maybe not all the particles will will have the same transition value. Okay, so how we can do that? Basically, we can create a random value on each point and use that random value to modify the fit function that we are using here. So let's make a little bit more room here, maybe separate our final outputs. I believe that I don't need the debug attribute anymore, and let's create first of all our random value, which will be created by the random function. It needs a source data to create the random value, so we are going to use the id. Also create a new parameter called seed, so we can have a control to create another version of the random if we want to do it. And then let's create some new variables that will modify the minimum and maximum edge values that we are going to use into the multiplication moment or a stage. I don't know how to call it. So okay, let's maybe call this like a minimum, and let's call this like a maximum. Let's got this thing. Don't forget to add the semicolon, and now let's add our variables into the function. Right now I just reorganized the code. The result is still the same. Right now the random variable is doing nothing. As you can see here, the points are still having the final size with all at the same time. So let's fix that. An easy way to do this is by just maybe multiplying the sorry, I am like rendering in my mind the idea behind the code. But an easy way to do this, if I after define the minimum and maximum values on the interface parameter, we can just multiply them with the random value, but also we can remap the random value, because the random function will give us a value between 0 and 1. So maybe we can just remap that to something between 0.8 and 1.2, which will mean that we are going to have like a 20% of variation of the value that I am defining on the manually defining on the interface. How to do that? Again, sometimes a few things can sound like maybe a little bit more complex than just before seeing how it works. So I can just create another fit function, but this one is the fit01. It does the same thing like the fit function, but it is for data that it is already between 0 and 1. So you don't need to specify the minimum and maximum input values. You will only define the minimum and maximum output values. So it is like a shorter version, which is I don't know if easier is the correct word, but it's more handy. Okay, so now I'm going to remap the random variable, and maybe, as I already told you, I'm going to remap it on a value between 0.8 and 1.2, which means that I'm going to multiply my data by 20%. So if I press now, I have a little bit of randomization, which is great. Okay, let's exaggerate this a little bit more. It is working, but maybe it's not noticeable enough. Um, as I already told you, I always create this kind of setup, but on different ways. I was thinking that maybe I can just create um, a value to control the minimum and maximum at the same time, but maybe I can just change the values right now manually, so it can be remapped by between 0.6 and 1.6. Why not? And as you can see here, if I change the seed value, the scales of the particles will also change. Okay, now it is working way better. Maybe also extend a little bit more the final size. Okay, they are behaving much better. Most of them are getting the final size after traveling some distance away from the coral. So yeah, I think that we can use this one for the final render. Let's update our cache. And well, I think it is extremely fast. I think that this particle here is static, maybe due to the simulation, so maybe we can remove it. Maybe those 4 particles. Okay, let's remove those particles very quickly. And I can delete the particles with a simple blast node like this, because we have on this scene like a stable point count. The points are not changing over time. If not, I will have to do it with another method, but that worked pretty well for this one. Okay, give me 1 second to read something here. Okay. Okay guys, so let's check how this is looking on the scene. Well, let me know if you like the particle street. If you want to learn something more about maybe that kind of particles manipulation or something. I also forgot that I need to update my USD cache of the particles. Or you can just say hi on the chat. That's a valid choice. Let's wait a few seconds for the USD cache. And now we should see way more particles on the scene. I'm going to enable the progressive rendering because I'm going to... Hey, Endless Lines, thanks for say hello in the chat. I hope that you are enjoying the streaming. Let me know in case if you have any question, or if you like the scene that I created for today. Okay, I can see the particles. I think that I like it. Maybe I want to reduce the size a little bit. Maybe I can show you a good trick about how to do that directly here in Solaris. because, well, this is the kind of cases of these kind of things happens a lot of time in production. Maybe, yeah, we assemble everything in Solaris, but mm, then you want to edit something and you probably needs to go back on the production process, even if you are working alone or with a smaller or medium team. If you know how to modify some kind of data directly here in Solaris, might be something more, sometimes more efficient, rather than do a few steps back, modify that is a small detail or change that you need to do, and then return into Solaris. I think that that's important, a key thing to learn how to modify some kind of data directly in Solaris without needing to go back, because that kind of back and forth sometimes can be like take a lot of time, you know. Okay, nice. Glad to hear that you are new in Houdini. There is a lot of places where you can learn more about the usage of Houdini. They have a pretty good section on their website called Learn. You can learn the basics there, and also I can recommend you to understand. I think like maybe the best um, first piece of advice for a new user can be that focus only on understand how to work with the nodes, and also try to understand how the attributes and the groups works. If you understand that foundation, especially on how to deal with attributes, you will have like an easier life in Houdini. So that's the key part in Houdini, because Houdini is like a very extensive piece of software. So sometimes you don't even know how some parts of Houdini works if you know how to work with the attributes and the groups, because that's the base of everything basically. So okay, now let's edit the particle sizes. Maybe I can also show you what I have here on the stage. Let's disable our render for 1 second. Here I have a little deorganized node setup because, well, because of two things. Yesterday I worked on this one on pretty late on my night. I was tired. And also I switched and tried something different in terms of how to assemble the scene, just because of the coral element, because it is a little heavy asset. I believe that it has around 6 million polygons. Even that Redshift and the viewport can handle that very easily with no problem. I was losing a little bit of responsiveness on the render interaction, so I was like trying to find a more efficient way to handle with that asset, especially because I do my renders on the standalone version of Redshift, which means that I need to export everything later as a Redshift proxy. And if I try to export the entire timeline with the geometry, with the original geometry of the coral, that can take more time to export, and also the file size will be heavier. So if I convert the coral into a Redshift proxy, which is like a, let's say, the geometry version, or how Redshift, which is Redshift, in case you don't know it, is an external render engine, which you can use it on multiple softwares like Blender, Cinema 4D, Maya, and so on. No, I created this model entirely in Houdini. I can show you. I can show you the model more or less a little bit quicker, because there is some parts of the graphs that takes a little time, a bit of time to cook. So I created, let me enable the wireframe just to show you. I started with a sphere, okay? This is like one of those interesting procedural modeling process. So I just started with a sphere. I deformed the sphere a little bit, and then I changed the topology for this kind of hexagons. I started to create some internal borders, and also created a group, but with some randomization to have some of the faces, just to delete some faces. Then I created the thickness of the coral. Let's call it coral, um, and subdivide everything. And then I created the main shape. After that, I just tried to do like a very small and quick simulation just to fit the coral part more or less correctly on the floor, and modify the coral with the sculpt node, which is new, I believe, since Houdini 20.5 or 20. No, I believe it is new on this version of Houdini. And yeah, just modify the sculpt like this one. Then I merge everything as BDB. I created some kind of roots. I just modify them with a few other nodes. Here from the same roots I created the hill or the mountain, which works as a kind of floor of the coral. And after have my roots, I just combine them with the coral and a few other small modifications and some reshape process, and I ended up with this shape, which yes has around a little bit more than 6 million polygons. So that's why I mean, it's not like the heavier geometry on the world, but I just want to work a little bit faster with it. That's why I converted the coral into a Redshift proxy, and then I just load it back again as a Redshift proxy here, and then I combine the other elements of the scene here. I loaded here the hill, here I loaded the seaweeds and the particles. Added a little background like this one, which is the one that has the blue gradient. And I only have one light because I am doing this kind of toon rendering, which doesn't need too much, too many lights on the scene. Well, the usual case, because of course, depending on each case, you might need a lot of lights. Okay, now let's do our final step. Let's reduce the size of the particles a little bit directly here in Solaris. Okay, I have the particles. I'm going to show you two ways to do this. Maybe one of them can be a little bit complex if you don't have experience with Houdini or with Solaris, which is Solaris is like the new, but yeah, but not too new at this point because I already have a few years. But it is the section of Houdini that works with the USD ecosystem behind the behind everything actually, and the USD is like the kind of newest workflow to build and assemble scenes. So, well, I think that can be like a 1 minute summarize of Solaris. But yeah, I definitely I already have a few years, maybe 2 years, since I switched from the common OBJ section of Houdini to Solaris, and definitely it is way better. You will find more advantages to work on this section instead of working on OBJ. Of course, at the beginning, maybe you might find a little friction to learn about some concepts and that kind of thing. But like everything else in Houdini, you will need a little bit of patience. Meanwhile, you are learning and understanding how this works. Okay, let's find our particles, which is this object called spores, and let's create a render geometry settings. On the render geometry settings, you will find the render geometry settings. But no, without the joke, the bad joke, this node will have like the custom properties that each render engine will offer you to control a few things for your primitives. Remember, here in Solaris, we call primitives basically for everything, or in this case, to my particles object. So here on the redshift section, I can just enable the global scale multiplier and just reduce it by half. And there you go. I have a good size here now. The second method. Let's try something with the second method. Maybe, depending on the time, maybe I can show you a third method, because yes, everything Houdini is like you will have thousands of methods to do the same thing. So you just need to decide to choose your battle. Okay, let's find the width attribute. Here I have like I'm checking the internal attributes and details that are contained into this primitive, and just press right click and edit property. Let's split this, and here I can just change the mode of this to multiply the current value by half or something like this. The downside of this method is that because right now if I expand the window a little bit more, I can see that the width attribute has 101 variations of the data, which is this I can see here on this little box. The downside of doing it with the edit properties is that it is flattening the data, so I will lose the variations from the from my attribute, which is in this at this moment it is called width, because in USD the P scale is renamed to width. And let's try another method to do it correctly. We're going to use an attribute wrangler node. The same thing, I'm going to load the primitive that I want to modify, and I'm going to enable this that to run the wrangler on array attributes. This means that my life will be easier to handle the attributes manipulation. So I can just press create a similar expression that the one that I already managed before in subs. I can just type width and multiply it with a parameter that I can create on my interface. So right now they will disappear, but I can multiply the size by the half. So let's refresh the render. As you can see, the particle has the original size here, and I can just reduce the size of all of them with this simple method. So these three methods are valid. So yeah, you can use the one that you prefer. Of course, the quickest one will be the using the render geometry node. The render geometry settings. But it is actually, as I told you, it is a good practice to start to understand how the attributes and the wrangler can also help you with some operations here in Solaris. Okay, I think that we are ready. I like how it looks. I like the size of the particles. Maybe I can increase it a little bit more. Yeah, something like that. And just as a final touch. No, well, actually, I don't have final touch. Let's set up our render. No, Karma doesn't have the redshift up. No, sorry, I misunderstood your question. I don't know. I don't remember if Karma has the similar option like a transform the width attribute. Let's check that here very quickly. But looks like not. So, in case if you are working with Karma, you will have to use the attribute Wrangler method rather than find something here directly. So actually this might be like a useful RFE, which is a request for enhancement that you can send directly to side effects. In case you don't know it, you can send those requests for enhancement very easily by just getting inside the website and just scroll down here into the report bug or RFE, and here you can put all the data that you want. If you specify everything with a lot of details, will be very probably you will have a better answer from them, because sometimes maybe some ideas can be lost on the process just because they are not described correctly. That's my advice for everything when you make a suggestion for a request for enhancement for Houdini, for Redshift, so on and so on. Okay, let's configure our render here very quickly. I just going to render this on the 1080 render, change this the compression of the EXR to WAA. I increase the compression value to have a smaller file size, because this is like a, yeah, this is for the challenge. I'm not going to need too much information, color information on the EXR. Also, I want to bake the OCIO color transform just to make my life easier to just upload the entry later on my YouTube channel. I believe that actually can. I usually don't use the automatic sampling for from Redshift, but because this is a toon render, maybe it does a good work. I don't know. Maybe, yeah. Let's disable the automatic sample and put a few values here very quickly. Something, I mean, this is like a toon render. It doesn't need too much stuff on the samples. Yeah, 7 seconds. So I believe this should work. Okay, and I want to show you one special thing that I have. I have this little node called Redshift Proxy Submitter, which creates and sends that job to my deadline, because I have here another machine for rendering. So this node is pretty good. Let me open deadline just to show you. And let's create a name for the sequence. Okay, another thing that I love from Solaris is that I can create takes, but very easily by just creating another branch from my scene. So at this point, the base scene will end at with this node, with the submitter for my deadline setup. But I also create a new branch to create the 9:16 aspect ratio for the social media. So I can just create it by pressing Shift and Enter. This is that's another big trick when you are working in Solaris. Let's create our camera. And let's override the aspect ratio by this. But this is the half part of the thing, because even that I already changed the aspect ratio, the resolution of the render setting, it remains on 16 by 9. So I can just override that very easily by creating another submeter here. Let's update the name. And no, you know what, sorry. Let me configure the submeter first, just to have everything ready for both renders. I select the render settings that I want to use, the camera, the frame range, of course, and also I have some custom deadline settings here, which maybe controls how many instances of the render will be created, because I split the render based on the video cards that I have on my machine, and I have two GPUs on this one and two more on the other machine. So this is ready. I can move it, can duplicate the node, and here I can change the resolution directly on the submeter node without needing to create another Redshift render settings, because this means that both renders will use the same render settings, but I'm just changing the resolution of the I don't know why the camera just make a huge zoom into my face. Maybe because I am moving my hands, I don't know. But okay, both renders will use the same render settings. So here also I can change the overscan of the vertical camera. Again, this is like create a kind of take with no effort. Maybe also check how this aspect is looking. Maybe increase the viewer size. I think that I can have a little bit more air on the top section. And position this like on the third section for my composition. Yeah, I like it. I think that it works pretty well. Maybe move it a little bit up. Just thinking that on the cell phone I will have almost this entire section covered by the interface buttons from Instagram. And maybe move it again a little light to the right, just to see the particles a little bit more. Okay, and this is ready, guys. At this point, when I finish a scene, I just need to send it to deadline. As you can see here, some information start to appear on the console, which means that the render is on exporting. Right now, USD stage will be created as a kind of checkpoint of my render. So let's say if I lose this zip file, or maybe on a future version we have a kind of compatibility issue, I always prefer to have like a backup USD file which contains everything from my scene, the render settings, the materials, and so on. Sometimes it can take a little bit of time, probably because you know how it is. It can be shy, because this is the first time that I show you this on the on live, so you know it can just don't work. Because that's how this kind of things works. But there you go. uh, I hope you like this live. I hope that you learn a few tricks about how to post produce actually some particle simulations. We created actually and randomized the p scalar of the particles, and also created a more organic reveal animation of that scale. um, and also we was looking, well, I show you a little bit of how I built the scene. Also I show you how to modify some kind of data, in this case the size of the particles, directly here in Solaris without needing to go back um, and modify that. So let me find the OBS to finish the transmission. Okay, I hope you like it. Don't forget also, please, to subscribe to my YouTube channel. Consider to share this with your colleagues. Nice. Glad that you like the final result and the colors that I used on this one. Also, this scene, it was inspired into the Scavenger's Reign series from Max. I believe it is on Max. It is a good one. And also, don't forget that this kind of toon materials can be acquired if you look for the You and Me Academy Toon Studio materials for Redshift. So thanks again for being here. Stay tuned on my Instagram and the YouTube channel to see the final render with some music. For this Mardini challenge, I acquired an Epidemic Sound account, and I am enjoying to making the music. Not making, but selecting the music and some sound effects for the scenes. So it brings definitely more life into the animations, instead of use like a extremely generic music for the clips. So thanks again. See you later on the next live.